Okay, hey, welcome to the shop. We're working on a boat.
It's a channel where we share tips and tricks to help you working on your boat and to have a great time while you do it. The jokes are campy, the production value is cheap, but the information is priceless. So stay tuned. My name's Eric with New Point Marine. Grab your tool bag. Let's work on a boat.
All right, hey, welcome to the shop. We are working on a boat. So today I think I would like to revisit our previous video that we did, the last one we put out just a couple weeks ago, where we measured for ground fault current on a boat. So the intent of that video was to demonstrate the tools and the methods and how we go about measuring for ground fault current on a shore power cord. And I didn't get too deep into the weeds of what causes a ground fault or what conditions we found, because I'm trying to keep these videos bite-sized and easily digestible. But we did get a lot of comments and some questions about it, so I thought we'd go ahead and talk about the condition that we found on the boat and how we resolved it, and address some of the questions and comments that we got, because some of them were actually really good. So stick around. Okay, so this video is intended to respond to our previous video. So if you haven't seen that one yet, I'd say go back and watch that, and then you can see how this should follow that and address some of the questions that came up. So I will link to that one here. So you can go back and rewatch it or watch it for the first time, but that should help to explain what we're talking about here today. So anyway, what was the condition that we found on this boat that caused the ground fault breaker to trip? So, there were some guesses in the comments, and if your guess was it was a neutral to ground connection on the boat, give yourself a high five. You are correct. It was a neutral to ground connection on the boat. The interesting thing about this particular one was where the neutral to ground was found, and it was actually directly related to this. This is the source selector switch. This is the rotary switch that allows you to select between shore or generator, and then use what power source you want without energizing the other source. Anyway, the way this particular boat had been set up since it was new was this switch was breaking the lines, or the hots. So it was breaking line 1 and 2 on the shore if we selected generator, and if we selected shore, it would break line 1 and 2, or the hots, on the generator. It did not break the neutral connection. So what was happening was, when our owner selected shore and plugged into shore power, there was a neutral to ground connection that was not being broken on the generator. So that allowed a parallel path for current to flow back to source. So we were actually conducting some of the neutral current away on the AC safety ground. The ground fault breaker saw that as an imbalance and tripped, and that's the way these things are supposed to function. So the solution to this was we replaced the switch and reconfigured it so that when we selected shore power, line 1, line 2, and the neutral on the generator were broken, and when we selected generator, line 1, line 2, or the hots, and the neutral on shore were broken, so that we did not have multiple neutral to ground connections in the boat. And that corrected his issue with tripping that breaker. So anyway, we did get a few comments and questions about this one, and I thought I'd address them because some of them are pretty good. All right, to address some of the questions and comments that we've gotten about this video, we'll start with one. One that I got was, why is it that we have to have an arrangement like this? Why are we just measuring these 3? Why not just clamp the cord and measure all 4? It's a great question. It would seem obvious. You want to see what's going on with the shore cord? Put your clamp on the shore cord and you'll see it. But you might see something other than what you're truly looking for. When I put my meter on the cord, my meter is looking for an imbalance, just the exact same as the ground fault breaker on the dock. It's measuring the current flowing through it, and it's looking for an imbalance. Now, if we measure the whole cord like this, there's a couple of things that could happen. One, and what is most likely, is we are going to see an imbalance, because if our boat is clean and everything entering our boat is leaving our boat by means of the short cord, we might have a neighboring boat that is putting current in the water, and we, on our meter, will see that external source on the AC safety ground. It's very possible that your neighbor boat could put current in the water, and that current is finding the path of least resistance through the water, through your underwater metals, through your boat's AC safety ground and bonding system, and back to source. And if your boat is clean and we clamp these three, we see 0. We clamp all 4. Well, now we get to see that external source of current. So when I look at my meter here, even though your boat is clean, I'm seeing something external, and it's giving me an inaccurate reading, and it can send you down the rabbit hole. So when we measure fault current on one boat, our particular boat that we're looking at, we're just going to measure just these 3. And if the boat is clean, I should see no imbalance here. I should see a nice 0 on my meter. The other thing that could happen if we clamp all 4 is there is a possibility that there's a problem on board your boat. Let's say you have a very small ground fault, but instead of putting it in the water, it's being conducted away on the AC safety ground. Well, if I clamp the 3 current carriers, and some of that leakage is being conducted away from your boat on your AC safety ground, as it should be, it may not be enough to trip the breaker, but you could be conducting something back to source on the AC safety ground. We'll see it this way. This will show as an imbalance because something is being carried here. If we clamp all of them together, well, now there is no imbalance. So we would see 0 and assume everything's fine. So when we're testing, we just test the 3 current carrying conductors like we have here. And if everything's working well, we should see a big 0. And we don't clamp the whole cord because it's going to give us an incorrect reading. Okay, so one of the other questions we got was in the comments was, why did we not measure the fault current on the AC safety ground after the condition was fixed? You saw me go there, and we measured on the 3 current carriers, line 1, line 2, and the neutral. But in the video, you don't see me go back and measure fault current on the AC safety ground after the repair was done to ensure that the repair was done well. Well, just like we talked about in the last bit here, if I do this, I'm probably going to see some external sources. So if we do the repair, we clamp our current carriers, and everything looks great and good, and I come over here and I clamp, I'm probably going to see something. I'm going to get a reading because there is going to be an external source of current somewhere being conducted on this. And since our ground fault breakers are only looking at these 3, what's going on with this really is not a big concern to us. And anyway, at the end of the repair, one of the things we do is put in a 5 milliamp ground fault protected breaker, and we load the boat up and try in every way we can to trip that breaker. And if we see very minimal or no fault current on a meter, and our test rig is holding, then we consider the fix to be good. Anyway, so I hope that clears up some of the questions about it, and I kind of, sorry, I feel like I left people hanging. I'm not saying what the cause of this was, but I really didn't want to get too deep into the weeds. But maybe neutral to ground connection on a boat would be a good topic for a video at some point. So until next time, keep working on your boat.